One last trick, and this is called logarithmic differentiation. So suppose you forget the derivative of a to the x, right? It's never going to be a problem, because suppose you have something like this. You're looking for the derivative of this function, y is equal to, say, 2 to the cosine of x. And you have no idea what the derivative of 2 to the anything is. So here's what you can do. You can take the log of both sides. So I'm going to take natural log of y equals natural log of 2 to the cosine x, but then I can put the cosine of x in the front. Now I'm just going to use implicit differentiation and take the derivative of both sides with regard to x. So on the left-hand side, the derivative of ln y is 1 over y dy dx. And on the right-hand side, ln2 is just a number. I'm going to carry that along, and the derivative of cosine is negative sine of x. So then when we solve for dy dx, we're left with y times natural log of 2. I'm going to put the negative out front, sine of x, and then we can go back because y was 2 cosine x. So we're left with negative 2 to the cosine of x times natural log of x times sine of x. So when you take the log of both sides, you're able to take the derivative of exponential functions. So that's a situation where it's okay to forget. Here's a situation where you could not do it otherwise. Suppose your function is something like this. Y is equal to sine x raised to the power of ln x. And this is a conundrum because you can't use the rule for exponential functions because that's not a constant. You can't use the power rule because ln x isn't a power. So the only way to handle this is to use logarithmic differentiation. So I'm going to take the natural log of both sides. When I take the natural log of sine of x, I'm going to bring down this exponent. So it's ugly. Let's take the derivative with regard to x of both sides of this. And obviously I'm going to have to use a little bit of product rule on this side. So on the left-hand side, the derivative of ln y is 1 over y dy dx. On the right-hand side, product rule, derivative of the first times the second plus the first times the derivative of the second. And then I'll multiply both sides by y. So dy dx is going to be, and y, remember, is sine of x to the ln x, and then we'll have times this whole thing. That's logarithmic differentiation.